set up.
Oh, did you take the good side?
I did.
Please. When the back truck comes, I'll get the lady and stuff in the pump down, alright?
Information for Judd.
Judd?
All customers travelling on Qantas flight QF1463 service to Canberra.
Yeah, don't lose your old one.
They will travel around the area. They will travel to Maitland, but and they just don't ever.
Mr. Taylor?
If they drop out or their performances are inadequate, we'll apply manual braking consistent with the rank. I might inch over towards the right to make sure we're not actually going to the left and infringing the spot. Left-hand turns are better than right-hand turns if we've got a dump once we get out over the water.
Auto brakes, I'll call speed brake up or not up, and the situation with the symmetrical with the reverse thrust.
Park brake set, starting 3. Starting 2 and 1. Okay, ground, we're ready for disconnect. Cheerio, bye-bye. Thanks guys, laps 20. Taxi check.
Before taxi checklist, anti-ice auto recall
Checked.
checked. Auto brake,
RTO.
flight controls,
Checked.
ground equipment.
Cleared.
And that's before taxi checklist complete. First right, Bravo 116 right, course 29-0.
Clear left,
Clear right.
as discussed. Okay, and before takeoff check.
Before takeoff checklist flaps,
20.
20. Cap reports received. Tax on before takeoff checklist complete. Clear for takeoff 16 right, Qantas 29-0.
Positive takeoff clearance.
Takeoff clearance confirmed.
Clearance confirmed.
Thrust set. 80 knots.
Check.
B1. Rotate. Positive right.
Gear up. Clear right.
All clear.
Okay, so my name's Peter Hicks. I was the glaciologist at Casey Base in 1980. I spent 9 months of 1980 at 2,000 metres up on the ice sheet, travelling towards Jumontville. And I'm going to do some commentary today when we travel from Sydney down over Tasmania and out towards Macquarie Island. We're looking at the weather and we're going to go straight to Cape Adare. But just near Cape Adare are two mountains called Mount Minto and Mount Sabine, which stick up above the clouds, and they're typically what the pilots and captains like to head for. So that's where we're going to go first. And then we'll fly around Mount Minto and Mount Sabine. Then we'll head out towards Cape Hallett, where there was a British base set up there in 1956. And then head south down between Coulman Island and the mainland, where there's some beautiful glaciers, the Aviator Glacier, the Mariner Glacier, some of the biggest glaciers in this part of the world. Head over Mount Murchison, which has got a twin peak. Then down over Cape Washington to the volcano Mount Melbourne, which is very noticeable because it's a conic shape. Then we're going to go into Terra Nova Bay, which is the site at the moment of two new bases and the old Italian base, which was once called Terra Nova, but is now called Mario Zucchelli, after the leader of the Italian scientific mission. From there we're going to go almost to the Dry Glacier Ice Tongue and the David Glacier, which are again big coastal glaciers, before we do a loop and turn around back out to sea and go back over Mount Melbourne, back towards Cape Hallett, and then we'll fly back over Cape Adare, past Mount Minto, and then back to Sydney.
few of the Balkans out just as Deception Island.
Okay. Hello folks, and it's Peter Hicks up in the cockpit. Welcome to the Antarctic continent. We're descending now towards Cape Adare. Cape Adare is a little point on the Antarctic continent itself, and of course people have been heading to Cape Adare as the first point for centuries. The early whalers came here. The islands that we just passed, the Balleny Islands, were visited by Balleny was a sealer in the early 1800s, came there in tall ships. But there was a lot of dispute about how people came and who was the first to land, and all of that's kind of probably in hindsight ridiculous stuff. But a well-known expedition that came here in the early 1900s had Borge Grevnik. He was a Norwegian who spent a bit of time in Hobart, and he became a teacher, and then he organised and joined with an expedition that had a few Australians on it that came here in I think it was 1900, and there was, on that expedition, there was a lot of different stories about who landed first. They always drew pictures of themselves jumping off the boat first, and I know there was some argy-bargy about who actually landed, but it is a desolate spot, and they all in their notes particularly said that it was wild, cold, and not a particularly good place to spend the winter. But they did spend a winter here, and they built a couple of prefabricated huts, which are still there. So we may get a chance to see them, although it's quite difficult to see them. But yeah, Borge Grevnik came back to Antarctica on 2 occasions, and that expedition, although in England and in Britain it was not well recognised, it did make it possible. A lot of people discovered that they could land on Antarctica then, and so it could be done. You know, the impenetrable ice barrier was not as bad as it might have been. Now, out the right-hand side of the aircraft at the moment, you'll be able to see some sea ice, the boundary of the sea ice in the Southern Ocean. Sea ice floating out. It is it's September. It's late September, late February. I beg your pardon. So, because it's February, a lot of the sea ice, you know, will be at its minimum. So I can see some sea ice now out the right-hand side. It's flat, and it leads back up to the continent itself. So you can see big swathes of sea ice, which is actually floating on the ocean. So it's bits of sea ice that get blown out with the local weather conditions. The patterns it makes and the way it lies on the ocean depends on the weather over the last 2 weeks or so. Sometimes it's covered in snow. But because we are coming to Antarctica at the height of summer, towards the end of summer in fact, we're going to see a lot of differentiation in the types of ice, because there'll be a lot of melt streams, and it hasn't been cold. A lot of the ice around the margins of Antarctica have blown out to sea. So straight ahead of the aircraft now, jutting up above the clouds, inland from Cape Adare, is Mount Minto, which is a good mountain for Australians. It was climbed by Australians back in the 80s. They had a long way to go. It's another very isolated peak, and they needed to get quite a long way from the coast to get there before they actually climbed the mountain. But we'll be going right around the peak of Mount Minto. It's 4,165 metres. So once again, twice the height of Kosciuszko. It's a real transantarctic mountain peak. And Cape Adare and the mountains we're going to run along beside are the transantarctic mountains, which basically form a line between two parts of the whole Antarctic continent, which is split in two between, not very imaginatively, but descriptively called East Antarctica and West Antarctica. So East Antarctica is the big craton, early part of the Earth's crust, and it has sitting on top of it the Antarctic ice sheet. Now, it's a good idea to get some perspective early on. We are visiting one small corner of the Antarctic continent. The whole continent itself is 2.5 times the area of Australia. So that gives you a bit of an idea of, you know, the scale of things and where we sit. We're going to a tiny corner just to the south of Australia, and the whole Antarctic continent is 2.5 times the area of Australia. And also the ice sheet. The ice sheet is a huge influence on the global climate, on everything that happens on Earth basically, is influenced by the size of the ice sheet that we're about to fly to. And it lies to the east of us, it lies over the South Pole, and it's enormous. At its centre it's over 4 kilometres thick, so that's 4 kilometres straight down of ice, and it's over 68% of the Earth's freshwater is locked up in the ice, and 90% of the Earth's ice is in the Antarctic ice sheet. So this is where the water is on planet Earth, the freshwater anyway. So we are flying south roughly at the moment, towards Mount Minto. And on the right hand side is, you can see the small peaks of the mountains. These are this is the transantarctic mountains coming to the continental coast and dipping down into the sea, just under the cloud that we can see out the right hand side of the aircraft. Away to the right, beyond the mountains, the ice sheet continues to rise up. Once again, remember, it rises up to 3,000 metres, so 3 kilometres thick, all ice. The dome up there is called Dome C, and it's one of the biggest domes in Antarctica. There's obviously domes A, B and C. And I think I can see Mount Melbourne ahead, maybe. Is that conic one? Yeah. Yep. Mount Melbourne, named for the Lord of the Admiralty at the time when Ross was first sailed down this coast, and a fantastic volcanic cone, because there's volcanic intrusion into these rocks that make up the transantarctic mountains. The actual geology of them is not well understood. They do mark a line between East Antarctica and West Antarctica. West Antarctica is all of that piece of land that moves up into the Antarctic Peninsula and becomes South America and the Andes. So that is, the Andes and the transantarctic mountains are very closely related in terms of geology. And what we're going to do now is we're going to fly around Mount Minto. So we'll fly around in a clockwise direction and then come back the other way. So people on both sides of the plane, you'll be able to see out. So don't go rushing out of your seat, but we'll take a good look around Mount Minto, and we'll go both ways. So you'll get plenty of time to have a good look at it. But here are some glorious snowy valleys. You'll see some of the local sort of alpine crevassing up at this height. Very similar to the tops of the Alps, you know, the Southern Alps in New Zealand. Very similar. Many more glaciers than there are in New Zealand. But we'll see some very big glaciers as we go down further to the south. But for now, these are the fields where the snow accumulates. This is the source of the rivers of ice, the slow build-up of the ice, the accumulation of ice of snow that then compresses itself into ice and becomes the rivers of that we call the glaciers. And you'll see the banding. The banding up here is typical crevassing, because the ice itself deforms and breaks, splits, and then the snow fills it in. So you can see the banding and the cracking fields, which are tension fields basically in the solid ice and snow up here. There is a lot of snow filled in, so a lot of the valleys at this height look quite smooth and calm, but beneath is ice heading down the slope. And people often ask, how fast are these rivers of ice moving? How fast do they move down? It's glacial. It's slow. It's about, up here it would be maybe 4 or 5 metres a year, something like that. Anything over 10 metres a year is a fast glacier. There are glaciers that we'll see later on where the ice can be moving up to 800 to a kilometre a year, but that is flying, and that is in the main streams of the biggest glaciers in Antarctica. These ones up here, it's more likely a metre or two every year. That's how slow it goes. You'll also see here how the snow gets some striation in it. It's sticking to some of the some of the layering in the rocks themselves. And sometimes that's a clue and sometimes it's not, as to the nature of the rocks underneath. There are some parts of Antarctica that have sedimentary layers, but many parts of the rocks where we are and that we're looking at now are metamorphic rocks. They're sediments that have been uplifted and then changed. And one of the clues to that is the sharpness of the ridges. The ridges are quite sharp, and that means they've been weathered. They've been under the influence of ice and snow and wind for a long time. And this local area of coastal mountain range, very dissected and very steep on the left of the plain. You can see the mountains are dropping down very steeply, and you can see a kind of a cushioning in the snow and the ice on the walls there. There's lots of snow that's bunched up and sort of dropping very quickly. We may get to see there's a couple of kind of wineglass glaciers on this coast where the ice slides down the valley to the seafloor at the Ross Sea and then spreads out like the bottom of a wineglass.
I'll get its focus.
Yeah, so we're going to fly straight over Cape Hallett. The British had a base which is, there's a dark cliff ahead, I can see it, but in the plane you won't be able to see it for a minute. But there's a sort of flattened field in front of the dark cliff. That was where the British base was at Cape Hallett. But they've taken the buildings away there now. It's been completely decommissioned. But it is an interesting spot. They did a lot of research in this bay that's just above, that we're just above at the moment. Past the Borchgrevnik Glacier. And this local mountain range is also named after Borchgrevnik, who was, it was interesting that he didn't have very many people skills, Borchgrevnik. He was a kind of a loner. They called him a lone wolf. A lot of English-speaking people, he was a Norwegian that they didn't take kindly to because he was confident, he was cocky, he wanted to do things, he wanted to discover things, and he didn't get on with people in a group very well. So now on the left-hand side, you can see the flat sort of beach below Cape Hallett, there's a dark cliff and which has also sort of a falling bit of ice or snow that's kind of wrinkled. Well, that beach there is where the British had their base. Yeah. But just to give you an idea of what it can be like on the ground down here in the bay, when that base was, or not that base, but that landing was made at Cape Adare, there was a young physicist named Louis Benecchi. He was Australian. He was about 22, and this is what he wrote when he first came to Cape Adare. One sight in bad weather of that sinister coast is enough to make a landsman dream for weeks of shipwrecks, perils and death. I can imagine no greater punishment than to be left alone, to live forgotten and die forlorn on this desolate shore. So it was pretty grim. And what can happen when the place is cloudy and not sunny like this is the sea becomes black. It's a very dark and black, grey and white environment, quite distracting and not very pleasant. Later on, Benecchi described the wilderness as approaching this sinister coast for the first time on such a boisterous, cold and gloomy day. Our decks covered with drift snow and frozen seawater, the rigging encased in ice, the heavens as black as death, was like approaching some unknown land of punishment, and struck into our hearts a feeling preciously akin to fear. It was a scene terrible in its austerity that can only be witnessed at the extremity of the globe. Truly a land of unsurpassed desolation. So he wasn't having a good day. But anyone who's been on the ground or sailed in Antarctic waters knows that blackness, that it can become very dark and quite strange, quite lacking in colour, the Antarctic polar seas. Anyway, we have the sun shining and how beautiful it is. And now to our right is the Borchgrevnik Glacier with very clear sort of moraine lines. The moraine's covered by snow, and the moraine is rocks that are carried in the stream of the ice, and they actually delineate where the glacier is flowing, and you can see that in the Borchgrevnik Glacier. You can see where the lines are, but they're covered in snow at the moment, so there is rocks in there, and that's why there's a differentiation in the snow. You can also see tributary glaciers. You can see all of the sort of alpine features of a huge mountain range with glacial ice flowing down to the sea. And on the left of the aircraft is Murchison. Yeah, Murchison on the right probably. I think the Borchgrevnik is smaller, but out to the left of the aircraft is sea ice. Quite an interesting sort of swale of sea ice that once again is broken up. It's not a uniform, and that's because it's been blown by wind, broken up, and then reformed again. Bits of thicker sea ice that might have broken off out of ice shelves sticking in it, and out to sea kind of a swirly, spumy sea ice that's reflecting the last winds that came off the main coast. And then we're also looking onto the top of Coulman Island, so we're looking onto permanent ice. And if you're on the right, you're looking towards the continental ice sheet where it rises up to the south, but also you can see there are individual mountain ranges out there. There's the Freiberg Mountains, there's a place called a neve, which is a snowfield. You know, it's a flat-topped, almost a plateau that's where snow accumulates and becomes this kind of reservoir of snow that then falls down into the glacial valleys. Gets blown down as well. And we're heading towards Mount Melbourne. And Mount Melbourne is a dormant volcano. 2,732 metres, so a little bit higher than Kosciuszko. Once again, it was discovered from the sea in 1841 by James Clark Ross, the captain of the Terra Nova. And he named it for who was then the British Prime Minister, Lord Melbourne. He was the Prime Minister when Ross's expedition was being planned. So the name of the glacier that's on our left, or that we're practically over, is the Mariner Glacier. And you can see that it's quite steep. It's there'd be quite a bit of flow. There's a lot of crevassing. When mathematicians in glaciology, they make models of the flow of glaciers, they use a formula that treats the ice as liquid metal, because it behaves more like a liquid metal than it does like water when it's frozen. So right at the bottom, they use these equations that describe the stress in the ice at the bottom of a glacier as being similar to a liquid metal, and that's why they can carry rocks, crush rocks. It breaks mountains, grinds down, you know, places like Kosciuszko and the Tasmania, parts of Tasmania that were covered by glaciers. You can see what it does. It just plucks the rocks out of the ground and drags them along. Yeah, and on the right of the plain, we're sort of heading up the middle of the two glaciers, is the Aviator Glacier, quite a long sweeping glacier with probably not as much steepness in it. It's more of a taking the long route to the Ross Sea. And then, of course, once the glacier gets to the coast, the ice floats, so it sits up and floats on the water. And that can cause this kind of pillowing that you can see out to the left of the aircraft. There's a sort of a long section of pillowing where the ice is being lifted up by the flotation of the ice on the ocean water. And then stuck in that is a bunch of bergy bits, like a jigsaw puzzle, that's because they've been cracked off and pushed around by the winds and then refreezing. But you know, there's really only one way to see this territory, and it's in a 747. It's fantastic.
Only cloud, but we are heading inland so that we can get a good view of Mount Murchison, graceful slope similar to Mount Fuji in Japan. There's one called Mount Sidley, but there's obviously been, you know, a crustal hotspot in this models of the flow of glaciers. They use a formula that treats the ice as it's frozen. So right at the bottom, they use these equations that describe. No renamed base. There's Mount Murchison.
Hey.
The sort of twin peaks.
Hello.
Hello.
And both the Aviator
Marvellous.
and
And what do you think? It's fantastic. I don't know why I waited so long. Maybe it's a really good on my own.
So when you're looking up at don't hide.
the ice. And once again, that could be tidal, it could be initiated by the tide lifting. So it's been snowing here for a while. There's a lot of, you can see it's quite soft on the mountain tops. and as it tumbles it kind of bunches up. So there's a fair bit of crevassing.
Hi, Rob. Or hi, Uncle Rob. In some cases. All right. Okay, let's go upstairs. Let's go and see where the real pilots sit. No.
We're heading up that way. There's some on the outside of the Cape. Flying to the east of Edna, and we're going to come up on the outside of it. British had a lot of trouble with this bay that's on the left of the aircraft now, because it's one of those places where the sea ice is unstable, so they could get across to explore the parts of the valley bay, and so they found themselves sort of marooned on this sandy bank near the Cape. Because on the seaward side there are some white.
Can I please have a cup if that's okay?
But just coming up on the right-hand side of the aircraft now is Mount Melbourne. You'll see that it's got that typical volcanic cone, and probably has pushed up, in a spot that's right on the coast. It just happens to be right where the Ross Sea meets the mountains, and also some good. On both sides of the aircraft now, some good examples of sort of broken sea ice. And this is what happens if you get a couple of nights of very still cold weather. The sea ice freezes. It freezes and it becomes about 1.5 meters thick, but it doesn't get any thicker than that because the ice acts as an insulator from the cold air. So sea ice is never more thick than 1.5 meters. And 1.5 meters is quite thick for sea ice. Sometimes it can just be a few centimeters thick. There's a little sill or dike cone on one of the slopes on the right hand side. If you get to look at Mount Melbourne, you'll see there's a little sort of pimply type volcano on the slopes. Remnant of when it was active, when there was lava coming out of it. So Mount Melbourne might be a little bit hard to discern because we've now got a background on the right of the mountains behind it, but it's 2,700 metres. It's higher than Kosciuszko, above sea level, so you can get an idea of the extent of the slope. It comes up pretty quickly. It looks quite benign, but it's a huge volcano. And it probably gives some scale to some of the icebergs and bergy bits in the stream there in the in the waters of the Ross Sea. Good little view of that little piggyback volcano that's on the slope there, just on the right of the aircraft now. Lots of volcanic ash, making up the cone. I don't think it's erupted, in living memory, but so it's probably extinct. But you never know with volcanoes down here, because Erebus is certainly still active. So there's a good, fairly close in on the right hand side, there's quite a good view of Jangbongo, the South Korean base now. Just to the left of that bay that's quite dark, up on the ridge. On the right hand side of the plane we're looking into the bay and we're looking at 3 small white icebergs just off the coast. There's a broken sort of patch of sea ice and then a snow-free rocky zone, and on the end of that is where the base is. Yeah. Yep. So there's a wispy sort of trail of spume that comes off from the icebergs, and just where that joins the iceberg to the right is where the base is. There's one particular building that stands out. Yeah, so the blue colour of the roofs, building roofs now on the right is quite prominent. You can see the blue roofing material. Over the top, yeah.
We will do it as figure 8 back to the other side.
Yeah, so we're going to keep circling now to the right, but if you look beyond the South Korean base across the bay, you may see the buildings of the Italian base, which is on the other side of this small bay.
Yeah, it's where it's rocky but very little snow, and then on top they build
So now out to the left, you can see the dry glacier ice tongue just on the horizon. So this is the stability that comes from having 2 or 3 glaciers empty into the bay at the same time, and then the ice starts to float, and the sea ice sticks together, so you get these long extensions out into the bay. They quite often do get broken off, but not sort of regularly, not as regularly as the sea ice gets blown out in the bays. And one of the problems if you're living on the base or you're moving around the bay and the base and the ridges that come down into the water is that the sea ice is not stable. In other words, it can be blown out by a blizzard at any time. So you don't want to go exploring across the ice and then, get on an island and then find the sea ice gets blown out. That's been the experience of several sort of exploratory parties. Sea ice is notoriously unstable under a blizzard because the wind blows down onto the ice and it blows it away out of the bay, and then of course you've got no way to get back. But in the winter it's relatively stable, but at each base they will know, where the stable ice is and where the unstable ice is, but it's still a little bit difficult to predict the kind of winds that might break up the sea ice at any time. Right, so the lighting is good on the left-hand side of the plane now to see Mario Zucchelli. The buildings are a bit more prominent. Red buildings, and the airstrip is pretty easy to see. There's a red building on the left, 3 small buildings just at the start of the road, and the road goes up to the airstrip. So they're working hard down there at the Italian base. Yeah. We're also having a bit of a look for a brand new Chinese base, which is further to the south of here, on the coast as well. So as I said, there's quite a bit of activity in the Terra Nova Bay region at the moment. Just a beautiful day here in Terra Nova Bay in the Ross Sea, and around about next Wednesday you'll remember this. It's you might wake up in the middle of the night and remember. It's a very unusual sight for Australians to see this kind of glaciated and snowy terrain. But here it is, mid height of summer in Antarctica. It's quite close in, but there is a good view just here. We're going out and around a bit. It's a long, thin red building on the left-hand side of a little bay. Quite close to the plane at the moment, but we're going to be a bit further away from it in a second. I just mentioned too that just at the moment, if you look at the water on the left-hand side of the plane, you can see the wind. So it's not often you can see what's going on with the wind, but you can see what's happening down there. There's a fair bit of streaking and but we are rather lucky to be here in February. It's for much of the year, or if we were to come in November, we'd have trouble distinguishing, the sea ice and the coast. It'd be much harder to see the features because the sea ice extends out to 200 kilometres off the coast of Antarctica in the winter, and it sometimes takes a long time to break away, whereas at the moment most of it is gone. You know, the only ice that we see is an ice tongue, which has got its own sort of stability mechanism from the feeding of the glaciers. Straight ahead of the plane at the moment is the ice tongue, which is floating ice. It's sea ice that floats, but it gets pushed by the stream of ice coming down the glaciers. And just if you're on the right-hand side of the aircraft, you can see this kind of, they're really mountains, but they're plateaus as well. And you can see the huge glaciers coming down from the ice sheet. This gives you a good idea of how the ice sheet rises to the south, to at the right-hand side of the aircraft now. That beyond the mountain, the ice sheet continues going up. So it's enormously thick, and it's an interesting feature because once you get past the Transantarctic Mountains, there's only ice, and it's just domes of ice and a huge expanse of what's really a kind of a desert. Never rains there, but of course it does snow. The snow accumulation, we called it, is something that we measured when we were on a traverse between Casey Base and Dumont de Ville on the coast. We were at 2,000 metres, and we put these posts into the ground and measured their height above sea level, measured their latitude and longitude, so we had a three-dimensional position with an accuracy of a cubic centimetre. That was something that we were trying to develop, what can be done with GPS now, but back in 1980, 30 years ago, for me, we were using a system called Doppler positioning, which picked up a constant frequency signal from a satellite passing by. And then there was an iterative process, so a sort of repetitive calculation that got the position better and better. So once you can get to a cubic centimetre accuracy of positioning, then when you come back a year later, the ice has moved and the position, you're able to measure the position because your accuracy is so good. That was the principle behind our traversing. We'd move 50 kilometres every couple of days, measure the position of a pole, and then move on. And those poles we could pick up on marine radars on the sleds. So there were like these little dots of poles all across the ice. And the idea was to measure the movement of the ice. There are patches of open water in the sea ice, and once again that could be tidal, it could be initiated by the tide lifting up the sea ice, bring it back down again, it breaks open, and then local wind blows it away. So sea ice is a remnant of the local weather, what's happened in the last few days of the weather. And I think we're here at a time when there's been a fair bit of snow recently, so it's been snowing here for a while. There's a lot of, you can see it's quite soft on the mountain tops. Just here on our left you can see some of the very vertical slopes that the ice is tumbling down, and as it tumbles it kind of bunches up. So there's a fair bit of crevassing, and then it'll flow away again, in This takes years, but the snow compresses at the top, and so it's difficult to see exactly what the ice is doing, but you get a premonition of it. So I'll just let you know a little bit more about East and West Antarctica. So East Antarctica is the big shield. It's the one with the ice sheet on it. It's a craton, so it's one of the earliest solidifications of rock on the Earth's crust. It's you've heard of Gondwanaland and Pangaea. These are the names given to the earliest continents. These are the first sort of scabs of rock, if you like, on the molten crust of the Earth. And then they get moved around by the subduction and the movement of the magma inside the Earth is what moves these continental plates around. And then West Antarctica, which the Antarctic mountains sort of divide off, is the Antarctic Peninsula that runs up to Elephant Island, and then South Georgia Island, and then the Cape Horn and Argentina. So and the Andes. So the Transantarctic Mountains probably were formed, or at least uplifted, at the same time as the Andes. And of course, Darwin was the first one who realised that the Andes had been lifted up, that they were once on the seafloor, because he found shells up above Valparaiso, and he realised that the movement in the Earth's crust takes bedding and rocks and sediments that were once at sea level, lifts them up into the mountains, and it deforms them, but they end up thousands of feet above the sea. So this mountain range that we're flying over is a kind of delineation between East and West Antarctica, between that more recent West Antarctic and the very old craton, which belongs with Australia, was once connected to Australia, of East Antarctica, which is where Casey Base is, it's where Mawson is, it's where the Norwegians have their bases around under South Africa. The whole of the Indian Ocean is the coast of East Antarctica, and it's all one, geologically speaking, one geological phenomenon, and it happens to have 3 kilometres, a big disc, 3 kilometres of ice sitting on top of it. Also quite interesting is that if you took the ice off the East Antarctic, if you took all the ice away, the rocks themselves would rise up, so there'd be new mountains formed around the edges of East Antarctica, because the ice depresses the continental rock of Antarctica into the mantle, so it sort of pushes it into the liquid mantle that moves the continents all around. The ice is so heavy that it actually pushes the rocks down into that. So if you took it off, the rocks would rise up and it'll be a completely different place, not to mention the sea level rising. But these are all sort of calculations and experiments, mind experiments or mathematical experiments that tectonic geologists do, trying to get to know, the way the convection currents in the Earth move the continents around. There are some beautiful tumbling, sharp little glaciers here that are all exhibiting the classic, crevassing, cracks that then fill in with snow. And right below us now on the right-hand side there are some mid-glacial linear crevasses which would go down, some of them go down hundreds of metres, if not kilometres. They're not as big as the ones, sometimes up on the continental ice. You get cracks like the one that Belgrade Ninnis fell in when with Mawson that go down at least maybe 500 metres or more, just out of sight. Incredibly deep cracks. But these ones would be 200 or 300 metres, maybe 50 metres up here at the top. and a great view on the left-hand side of the top of Mount Murchison. Lots of steep alpine valleys. Sometimes the snow is tumbling out. It's so steep the snow is tumbling down the couloirs. A very steep glacier just there below the two peaks. See it. When we get round, we'll go all the way around and then we'll come back the other way so that people on the right hand side can get to see the peaks as well. Just glorious view. So just on the right, you're looking out to the south. That's heading towards the top of the dome, and you can see how the ice on that side of the mountains is completely overwhelms the mountains. So it gets higher than the mountains and it becomes a flat, very slow rising dome, and it heads to the north and finds the coast at Commonwealth Bay and Jumontville and Casey, that whole so-called Australian coast. And when Mawson in 1912 came, he came here in 1909, I think, in search of the South Magnetic Pole, which is it's a spot on the Earth's surface where a magnet that would be at the centre of the Earth, comes out of the Earth's surface. So that's where the magnetic force lines are vertical, and that's how they could, using a compass or something that's magnetic, it points straight down when you're at the pole. And back in 1909, that was on the Antarctic continent. But since then it moves, because the centre of the Earth, the rocks and the mantle inside the Earth wobble a bit, or they move, and so the convection currents create the magnetic field in the first place, the molten rock. So the pole wobbles and it moves, and in fact the pole is moving about 15 kilometres a year, 20 kilometres a year, and since Mawson's day it's moved off the coast. So it's now in the Southern Ocean off the coast of Jumontville, the French base. So that's rather interesting, because Mawson initially came down with Edgeworth David, who was a geologist, and they were very keen to get to the South Magnetic Pole as a scientific exercise. And nowadays, if you want to get to it, you have to take a boat and chug along with the magnetic pole as it moves. But back in Mawson's day, they wouldn't have known much about the Transantarctic Mountains. They kind of knew they were here, but they were more interested in just what it was like to be on the coast, or at least they were exploring. And so when they got to Commonwealth Bay, they decided to put the huts up there, and didn't realise that it's at the base of the huge dome, which is the ice sheet. So that's the wind, the air, the katabatic winds, as they sink down the ice, they're just unrelenting. At times the air is just continuously blowing past them. So that's why it was the windiest place on Earth. This kind of territory would have been inaccessible to them and probably unknown to them. So that's quite interesting. They moved across terrain that was a lot flatter. Still had coastal crevassing, still had a lot of some relief. But if you visit the Australian coast, the view and the actual feeling of it is much different to this part of Antarctica. The same is true with the Antarctic Peninsula near South America. It's much higher and steeper, quite rugged, similar to this coast, but a little bit more steep, a little bit more like fjords, a bit more like maybe New Zealand with snow and ice. But the Australian coast is relatively flat. The cliffs are about 30 metres high around Commonwealth Bay at the most, and then the ice sheet just travels up very gradually to the south of that. So we're just flying to the east a bit, and we're going to come up on the outside of Cape Hallett. Cape Hallett is where the British base was, established in about 1956, taken away in about 1991. British had a lot of trouble with this bay that's on the left of the aircraft now, because it's one of those places where the sea ice is unstable, so they could get across to explore all the parts of the valleys on the left and get up onto the glaciers, but they weren't sure that the ice would stay, and so they found themselves sort of marooned on this sandy bank near that black patch, if you can see the bay off to the left of the aircraft. But we're going to go to the outside, to the Ross Sea side of the Cape, because on the seaward side there are some wineglass glaciers where the ice tumbles and then spreads out at the bottom. We're hoping to catch some of those, but the cloud is kind of clear a bit here, so we might see that. You can see the cloud is actually lying where the glaciers are. It's just in against the Cape, but we'll fly down that way and have a look. Fly over the ice, the sea ice. So just here on the left of as you can see the Cape, you can see the sun glinting on the Cape as if it's wet. Looks like it's wet. But just below that on the left, you can see our actual wineglass place there, where there's a chute, and the snow and the ice is coming out, and the ice is spread out down the bottom. There's a few of those along this side of the Cape. Very, very steep chutes where the ice spends all its time vertical and then spreads out like a fan onto the sea ice below. There's one or two of those as we go up this edge of the Cape. This patch of sea ice, you can see it's made up of all kinds of broken up bits, so you get a couple of still nights, and the way that shadow from the Cape fills in the coast would freeze it, so it freezes this section of sea ice into the Cape. It looks pretty new to me though, that probably it's only been frozen in the last week maybe. Still has that fuzziness around the edges, which is a sign of forming ice rather than broken out sea ice. Not much snow. So just below the left-hand side of the aircraft, you can see some of these ice floes now. There hasn't been a lot of snow to feed them actually. I've seen them bigger than that. You can see how they. Yeah, only that one at the beginning really spreads out much.
Oh no, I guess that you see that here for it. That's it. All good?
It's interesting because there's not as much snow as there usually is to feed them. But we're just about to go over the northern end of the Cape, and just tucked in at on the western side of the northern end, that's the left-hand side, is where the British base was. You'll be able to see it if you're, it's a pretty obvious place to put a base when you can see it. But as I said, they found themselves isolated out there on the Cape and hard to get up because it's very steep up onto the Cape, and they couldn't get across the bay, so the base was abandoned, and then eventually the huts were taken away. Yeah, so you can see now why that would be an attractive place for a base. It's the only place really along that coast. It's a bit protected by the Cape, but turns out to be not a great place to have a base. So. So we're flying to the north now. We're flying towards Mount Minto and Mount Sabine, and on the right-hand side we've got a great view of the kind of terrain that those climbers back in 1987, I think it was, that climbed to the top of Mount Minto had to traverse. They had to come from the coast, from Cape Adare. Cape Adare is under the cloud at the moment on the right-hand side of the aircraft, but you can see this this heavily, very steep terrain on the right that they had to find their way up. So people ask me, what's it like travelling in this kind of terrain? Well, it's tough stuff. It's crevasses, it's soft snow, it's everything that makes it tough to make any headway. You can come up the ridges, which is what they did. They came up the ridges, but navigating them is a tricky business. So we're just passing Mount Minto again. Cape Adare on the right, underneath the cloud that's around the coast. So this is the last we'll see of the Transantarctic Mountains here.
Yeah. Thanks.
So this is the poetic part of the journey. The sun getting lower, and consequently that little top layer of Water vapour comes into the valleys. So below us you can see there's some mist starting to form in the valleys. In some places, the shadows are getting longer. But this is a unique and a very interesting perspective on the Transantarctic Mountains. It's a part of Antarctica that lies between the two large masses, or large landscapes if you like. West Antarctica is very fjord-like, but East Antarctica out to the south is enormous. It's another 5 hours flying from here to the South Pole, so that gives you an idea of how far it would be, and it's 5 hours home. So we're sort of on the coast, and we're still 5 hours back to Sydney. So it gives you an idea of the scale of the continent. Absolutely gargantuan. And this sort of view is the thing you wake up next Wednesday morning thinking, was I really there? So we're sort of heading back to the north. Just a reminder that in the summer here, the sun doesn't set if we're south of the Antarctic Circle in this area. So, at the end of the day, but the sun just goes round the horizon. Inside the Antarctic Circle, there's 6 months where the sun goes round the horizon. That's the summer. And there's 6 months where it goes below the horizon and stays below the horizon. So that's something to consider. Casey Base, where I stayed and spent most of the year, is just outside the Antarctic Circle. So it's like in September when we were coming back from Travis, there was that glorious day when the sun rose for the summer, and that made a big difference to our lives, to our mood when the sun came back. But for the rest of the year, from March to September, it's dark. So it's great to be able to see it like this. It's a glorious perspective on a little corner closest to Australia of the Antarctic continent. And if you're on the left and look out there, you can imagine that the ice sheet continues to rise. It goes up to 3,000 metres, and there's absolutely nothing on it. There's none of those peaks of mountains or rocks. It's just flat ice, and it's very hard to navigate out there. It's very hard to even discern where you are, because you can see, even now we can't really see the horizon. We can just see vaguely where the mountains come in. But if you imagine that being flat snow with nothing on it, it becomes a very difficult place for flying and for a lot of things. Anyway, I hope you enjoyed Antarctica. It was a pleasure to talk to you. And if you see me in the cabin and you've got any questions, come and say good day. Okay, bye for now.
Well, hi everyone, Captain Greg Fitzgerald here. What a great day we've had in Antarctica. We tracked down to Cape Adare, which unfortunately was covered in a little bit of cloud, but from there over to Mount Minto, circled around Mount Minto a few times. What great viewing. Down the Tucker Glacier to Hallett, then to Coulman Island, then across to Mount Melbourne, where we also did a few laps of Mount Melbourne. Then right at the base of Mount Melbourne we saw the Jangpongo, which is the South Korean base, and we were lucky today because we're able to see the 3 bases in Terra Nova Bay of Jangpongo, Mario Zanchelli, which is the Italian base, and also the new base that the Chinese are building down there. At that time we changed our seats and basically came back up the mountains, looking at the bases again, back to Mount Melbourne and then back to Mount Minto and then home. I hope you had a great day. It's been fantastic viewing. You really have struck gold with the clarity of the air and all the sights you saw today.